Okay, so welcome back everyone after a rather long break, and probably this is going to take longer than the Eid vacation to load up. Did you guys submit your assignment? I checked in the morning. I think I saw like 8 submissions at that point. I haven't checked in the last 10 minutes or so. Maybe I'd see a few more submissions, but that's probably not going to change a whole lot. Actually, I can check on my phone. Yeah, I think that's faster. Let me just do that. Okay, yeah, that's a whole lot of improvement. From 8, it went to 9. Yeah. Anyway, just so you guys know that we had an assignment due, and I don't intend to extend the deadline. The intention of giving out this assignment is for you to judge where you stand at this point, and also for me to understand how this is going to go. All right, so jumping back to what we were talking about, we started talking about functional programming, but I didn't talk really about functional programming. I showed you how we can do lambda expressions. Okay, but I also didn't tell you what lambda expressions really are. What I talked about in our last class before the vacation, it was just about how to write anonymous inner classes, right? And then we saw that we don't need the names anymore. We could write functions just like that. So just to recap, you see what we had before Java 8 is that we had to declare some classes for comparison. I mean, this was the example. It's not just limited to comparison, obviously. It can be applied to a whole lot of things, which we will see some of those things today. So, for example, student comparator by ID in ascending order, that's an implementation of an interface, and you have to write the body. So that was one way of doing it. The problem with this was that you have to give it a name. You can make it a separate class. Here we have it as an inner class. Having it separated as a separate class would mean that you'd have to create separate files for them, and at some point it's going to be a lot of classes, and they wouldn't make much sense, right? You're only using them for one particular purpose, but if you give your code base to someone else, that person is going to look at all these classes, and they wouldn't have any clue why these things were created. So that reduces the readability and also the maintenance of the code base after a certain point in time. That's why I say that inner classes are probably a better place to put them, because you know that these are all related to this particular class, and once you get into this, only then you'd probably dig into it, try to understand what's going on. And if you look at this class, this inner class, maybe that doesn't make much sense. Why do I declare this? I don't really have some clue here. Obviously, we should have had written some documentation which could have helped us understand the purpose of this code, but at this point that's not there, and that's really not helping. So that's just to let you understand the intuitive idea of why we need all these things, why we go through these modifications. That was one style of coding back in the days. We used to declare these comparators as inner classes. Now, when you move into anonymous inner class, you don't have to give it a name, and you only use it where it is needed, right? And that's why this is more readable from the previous version, because someone new, or you yourself, looking at your code maybe 6 months from now, you probably feel that this is a totally new thing for you. So here we use a comparator, and we don't give it a name, and it's localized right at this point. You'll probably try to understand what's happening. We are trying to sort this. Sorting how? Based on this. So this is more readable, this is more understandable that way, and this is definitely better. Now when we go for the lambda expression, and we have like 3 versions over here, you see that we went through gradual improvement. Rather than giving it a name, why bother with the name of the interface, why bother with the name of the method? You don't really need that. We got rid of that. Now the gradual improvements that came on later on is that you don't need the name of the data type over here because they can be inferred. Right? You're sorting an array of students. What would be the members in that array? Obviously of student type. It can be integers, right? So that can be automatically inferred. That's why in this version 2 we left it out. Java compiler can understand that. This is also valid and this is also valid. So since this is more concise, maybe we go for that. And the final version that we have right here, you see that here we can see, well, this is actually not the final version. The final version is even better. This version 3 tells us that since this is a one-liner, you don't have to put curly braces over here. Okay, so no curly braces, and you don't even need the return. So these things, they can go away. You're left with a single line, and it just looks pretty. In the final version, we are using something totally different. We are using comparator class, and we're comparing by something which is written right here. Okay, so we are comparing all these students by their GPA in reverse order. This is all very readable and it's all very concise. It all makes sense. Okay, and that's one of the reasons why I wanted this thing to come right in front, because when we move on to the frameworks that we're going to go for within a few days, like the Spring framework, Hibernate framework, or even when we go for Vaadin, we'll see that a lot of those codes written in the examples, in the documentation, they're written with lambda expressions now. They have rewritten those things. So for you to understand those things, you have to know what's happening under the hood. So that was the primary reason why I wanted to bring up these new Java 8 features. Well, they're not really new, really. Like Java 8 was released maybe 2 or 3 years back, so this is already backdated. I mean, this is very much in use, but this is not really fresh out of the box now. Okay, we have Java, I think 11 is out, and it comes with some very cool features, like you don't even have to write the data type. You just say var this. Okay, right now we write int x or double y. You don't have to write that. You have to give the name of the class and then you declare an object. Now all these things can be inferred. It can be understood by the compiler. You just write var. That's in the latest Java releases. From Java 9 onwards, we do that. So that's like a cool new feature. Other languages had that from before, but this is a new thing coming in Java. Java, like all of the languages, it's just going through a lot of modifications. Things are getting easier and easier for people to learn programming, and also for us to develop code faster. So we will get there. I mean, I'll talk about some of those new features, the JShell and other stuff, what's new in Java. Since this is an advanced Java course, this is really a nice place to talk about those new things that are coming out. But right now, let's stick to Java 8 and let's just talk about these things. So for now, we have learned how to get rid of anonymous inner class, write code in a concise way. So that's that. So before moving on into some more new stuff, I wanted to talk about a few things over here, because I have mentioned the names, but I never really introduced them in a formal way. So I talked about lambda expressions, and things are really oh, I see what happened. I'm only getting half the screen over here. That's why my handwriting is so big. Let me do a two-part video over here. I'm going to finish recording this just because I think I'm recording 2 screens. I'm not sure.